Hey everyone, in our previous session, we have discussed about decision tree algorithm in machine learning. We have seen how we can utilize decision tree algorithm in order to solve the classification problem. This session is dedicated to understand the math behind decision tree algorithm. In this session, we will understand few important concepts and the mathematics for those concepts. We will go through entropy, Gini impurity and information gain. These three are very important concepts for decision tree algorithm. Let's start with entropy. We know entropy is the measure of disorder or uncertainty. We will understand entropy with the same example we used during our previous session when we learned decision tree algorithm. Remember, entropy value lies between 0 and 1. The mathematical equation for entropy is summation of I equal to 1 to c minus pi log base 2 pi, where pi is the probability of class I and c is the number of classes. For simplicity, here in our example we have taken a binary classification, because if you see our target column or dependent column, which is rain, has only two different possible values, yes and no. That's why it is a binary classification problem. We know decision tree creates a tree-like structure to predict the outcome. Based on this dataset also, decision tree will be creating the tree structure. I have drawn only part of the tree structure here, assuming that outlook feature has been chosen by decision tree as root node. Let's evaluate the entropy minus probability of yes log base 2 probability of yes minus probability of no log base 2 probability of no. We have to evaluate this in order to evaluate the entropy, because in our case c equal to 2. Hence, this part will be when the value is yes and this part will be when the value is no. We have 3 yes among total 8 samples, and that is the reason probability of yes will be 3 by 8. Log base 2, again probability of yes, that's why 3 by 8. We have 5 records which have no's among 8 total samples. That's why 5 by 8 will be the probability of no. Log base 2, 5 by 8. If we evaluate it, the answer will be 0.95. This is a very high entropy value. That means uncertainty in this dataset is more. Considering entropy value lies between 0 and 1, 0.95 is a very high value. Let's see this graph now. In this graph, in y-axis I have plotted entropy, and in the x-axis we have probability of yes. Now the probability of yes is 0 when we have 0 samples among total 8 samples. Probability of y will be 1 when number of yes are 8 and number of no's are 0. Both these scenarios are nothing but pure split, and hence the entropy will be 0 for both the cases. However, if the number of yes are 4 and number of no are also 4 among total 8 samples, then that will be the highest entropy or highest uncertainty. That is the reason the entropy value for this point will be 1. Based on our calculation, entropy value is somewhere here, which is very high. Now, as we have understood how to evaluate entropy value, let's go and understand how Gini impurity is and why do we need it. Like entropy, even Gini impurity measures the impurity in the dataset. We can compute Gini impurity with the help of the formula 1 minus summation of I equal to 1 to c pi square, where pi is the probability of class I and c is the number of classes. We have taken the same example as entropy. Now let's calculate Gini impurity for this dataset. As this is a binary classification problem, hence c value will be 2. So Gini index will be 1 minus the square of probability of yes plus the square value of probability of no. Probability of yes will be 3 by 8, because there are 3 samples where we have the value yes among total 8 samples. Probability of no will be 5 by 8, because 5 no's are there among 8 samples. If we evaluate this, we get 0.47. Now apparently you will feel that Gini impurity is giving less value than entropy. But remember, Gini impurity value lies between 0 to 0.5, whereas entropy value lies between 0 to 1. Let's check the graph now. In this graph, I have plotted Gini impurity in y-axis and probability of yes in x-axis. Probability of yes is 0 when the number of yes are 0 and the number of no's are 8. Similarly, probability of yes will be 1 when all the samples have yes value. If we plot Gini impurity, the curve will be something like this. When the number of yes are 4 and number of no's are 4 among 8 total samples, the value of Gini impurity will be 0.5. Hence, this is the highest value of Gini impurity. By default, decision tree uses Gini impurity because unlike entropy, Gini impurity calculation does not have log. Considering log is a costly computation in computer science, by default, decision tree uses Gini impurity. And as we know, the mathematical equation of both entropy and Gini impurity, let's calculate information gain. By using information gain, decision tree algorithm evaluates the effectiveness of the feature to predict the target variable. On the other hand, by calculating information gain, decision tree algorithm identifies the best feature to take as decision node or the root node. The equation for information gain is Ig y comma x entropy of y minus entropy of y when x is known. Here y is the target variable or the dependent variable, x is the feature or the independent variable. In our example, if we want to evaluate the information gain on outlook feature, the calculation will be something like this. It is not very hard to understand. Let's go through line by line. Information gain of rain column knowing outlook values will be the entropy of rain minus entropy of rain given outlook values. Entropy of rain we already have calculated. The value will be 0.95 because we are calculating probability of yes log base 2 probability of yes minus probability of no log base 2 probability of no. If we calculate this, the value will be 0.95. In order to calculate this part, we will be calculating entropy for each different category of outlook column. And finally, we will be evaluating the weighted average to get entropy of rain with outlook. Here we are evaluating the entropy of rain given outlook is cloudy will be 0.91. How we are calculating it? The same entropy equation has been evaluated here. Minus probability of yes log base 2 probability of yes minus probability of no log base 2 probability of no. We have evaluated the same thing when outlook is sunny, when outlook is overcast and got 0 and 0.918 respectively. Then what will be the weighted average value for entropy of rain given outlook? We have total 3 samples where outlook is cloudy among 8 samples into 0.91 we are taking from here, plus we have 2 sunny days among 8 different samples. That's why 2 by 8 into this value, plus we have 3 overcast samples among total 8 samples into 0.91 we have taken from here. Once we evaluate it, the value will be 0.685 and the total information gain of rain column with outlook feature will be 0.954 because we have this value minus 0.685 we have this value. The information gain is 0.27. Similar to outlook, our decision tree algorithm evaluates the information gain on rain column with outdoor temperature, humidity and airspeed to evaluate and understand which column to choose as root column. If you evaluate information gain on rain column with airspeed as an exercise, you will see the value will be higher than the outlook column. It is 0.95. Remember, decision tree algorithm evaluates information gain for all the feature columns and choose the feature which is giving highest information gain value. In this case, airspeed will be chosen by the decision tree. Let's understand the takeaway from this session. In this session, we have discussed about all the mathematics behind decision tree algorithm. Now we know how entropy will be calculated with the help of this mathematical equation. We know entropy lies between 0 and 1. High entropy is bad from machine learning point of view. Now we are aware about Gini impurity equation. We even can calculate the Gini impurity for a dataset. We know Gini impurity lies between 0 and 0.5. The computation for Gini impurity is fast and cost effective because there is no log involved in the equation. And finally, how decision tree calculates information gain for each and every feature column to identify the feature column which has highest information gain as root column. Hope you have realized that the mathematical equations for decision tree algorithm are not too complex to learn. Thanks a lot for watching this video.